Hello everyone. So in today's video, we will solve this radical equation that you see on the board. Now this radical equation is made up of three terms. The first term is negative x. The second term is square root of x plus 7. And the third term is negative 1. Now the variable in this equation is x. So in order to solve this equation or find the roots of this equation, we have to isolate x. Now in the middle term, x is under the square root, but the other x term is not under the square root. So the first thing we'll do is separate the square root terms from the non-square root terms by moving the non-square root terms negative x and negative 1 to the right side of the equation. So first we can add x to both sides. So by doing that, the x's on the left side will cancel each other out. So we get square root of x plus 7 minus 1 equals x, because 0 plus x is just x. Now we have to move this negative 1 to the right side of this equation. So we will add 1 to both sides, because then the ones on the left side will cancel each other. So we are left with square root of x plus 7 equals x plus 1. Now we have to get rid of this square root on the left side of the equation by applying square to both sides of the equation. So on the left side, the square and the square root cancel each other out. So we are left with x plus 7 equals x plus 1 square. Now we have gotten rid of the square root. So now we are left with a polynomial equation. So we will solve this equation. So the first step is to distribute this square on the right side of the equation. So we get x plus 7 equals x plus 1 times x plus 1. By expanding the square, we write the term twice, because square means multiplying the term by itself. Now we can do the distribution on the left side, on the right side, by doing FOIL. So we distribute the parentheses. So we get x plus 7 equals, so we do x times x, which is x squared. Then we do x times 1, which is x. And then we do 1 times x, which is x. And then 1 times 1, which is 1. So this is the result of this distribution on the right side of the equation. Now we can combine like terms. Now on the right side, x and x are like terms. So we get x plus 7 equals x squared plus 2x plus 1. Now this is a quadratic equation, because the highest power on the x is 2. So we can combine all the terms by moving the terms to the right side of the equation. So we know that x and 2x are like terms, 7 and 1 are like terms, so we have to gather them. So we can continue on this side. So I'll write the equation first. So x plus 7 equals x squared plus 2x plus 1. So we can gather the x terms by subtracting x from both sides. So the x's on the left side, they cancel each other out. So we are left with 7 equals x squared, and then we do 2x minus x, which is just 1x or just x. Now we have to gather the number terms. So we can move the 7 to the right side of the equation by subtracting 7 from both sides. So the 7 on the left side cancel each other out. So we get x squared plus x minus 6, because 1 minus 7 is equal to negative 6. So now this is a quadratic equation we have to solve. Now this is a simple trinomial because the coefficient of the x squared term is 1, or the invisible 1. There is no number with it. So we can use the sum and the product rule. So we have to find two numbers whose sum is 1, which is the coefficient of this x term, and the product is negative 6. 1 is the coefficient of this x term, this invisible one with x, and the product is this number term at the end. So now we have to find the two numbers. The first pair of numbers that come to my mind that multiply to negative 6 is negative 1 and 6. But I cannot get a sum of 1 from negative 1 and 6, so this pair is out. Now I have to think of another pair. So the next pair that comes to my mind is negative 2 and 3. So this pair works because negative 2 plus 3 is equal to 1, and negative 2 times 3 is equal to negative 6. So these are the numbers I'm looking for. And now we can write our factored form. So we can continue here. So our factored form will be, so 0 equals x minus 2 and then x plus 3. Now we get two cases. So we set each factor equal to 0. So I get x minus 2 equals 0 and then x plus 3 equals 0. And now we have to solve for x. So in the first case, so I add 2 to both sides to cancel out the 2's on the left side. So I get x equals 0 plus 2, which is 2. And in the right side, we subtract 3 from both sides. So the 3's on the left side cancel each other out. So I get 0 minus 3, which is equal to negative 3. So these are the two solutions I get from this equation. Now we have to check if any of these roots are invalid. So we can sub in x as 2 and x as 3, negative 3 in the equation to see if the left side becomes equal to the right side. So let's start with x equals 2. So we'll sub in x as 2 in the given equation. So we get negative 2 plus square root of 2 plus 7 minus 1 equals 0. So we get negative 2 plus square root of 9 minus 1 equals 0. So negative 2 plus 3 minus 1 equals 0. The square root of 9 is 3. And then when we add these numbers, we get 0 equals 0. So x equals 2 is a valid root. Now we can do the check for x equals negative 3. I'll do it in a different color. So we sub in x as negative 3. So I get minus negative 3 plus square root of negative 3 plus 7 and then minus 1 equals 0. So I got 3 plus square root of 4 minus 1 equals 0. And then I get 3 plus 2 minus 1 equals 0. Now I get 4 equals 0. So in this case, the left side is not equal to the right side. Negative 3 is an invalid. So now we can write our closing statement. So the closing statement is, so the root of the equation is x equals 2. So there is only one valid root for this equation. So these are the steps you have to keep in mind to solve this type of radical equation. So I hope you'll find this video useful. Please share it, like it, and subscribe to my channel. Thank you very much and have a nice day. Bye.